Okay, so we're going to talk about the octet rule today. And so the octet rule just simply states that atoms are going to either gain or lose the valence electrons, to achieve a stable valence level, or an octet. So stable valence level occurs when it has sp2, sp3 configuration for its electron notation. And that's going to correspond to the nearest noble gas. Okay, so think of this as like your set of 8, and that's why we call it an octet. Right? This is going to occur during bonding, so either ionic or covalent bonding, and that's going to help form that compound. So we'll talk definitely more about that bonding when we get into bonding in our next unit. All right, so next we're going to talk about the octet rule. So we have metals and nonmetals are two types of elements that we're going to be talking about. So metals are going to lose, and we talked about this in the last unit with losing or gaining electrons. So metals are going to lose their valence electrons to get a full valence in the next level below. So let's take an example of aluminum. So if I write out the notation of aluminum, 1s2, 2s2, 2p6, 3s2, 3p1. Remember that our valence electrons are those outermost energy levels. So our outermost energy level is 3s2, 3p1. So we have 3 valence electrons. So our atom is going to lose those 3, and the new configuration of our ion, so remember the ion is going to be Al plus 3 because it lost 3 electrons, will be whatever's left over. So 1s2, 2s2, 2p6. And if we look at what's left over, notice that ending, there's our octet. We have our s2p6 configuration. So metals are always going to lose their outermost electrons, their valence electrons, to get to that octet configuration. Nonmetals, on the other hand, are going to gain valence level electrons to get a full octet. So if we look at an example of sulfur, 1s2, 2s2, 2p6, 3s2, 3p4, our valence electrons is at 3s2, 3p4. Now, in order to get to that octet, I need 2 more electrons in that 3p. So it's going to gain 2 electrons, and those 2 electrons are going to go into that 3p. So our ion, which is going to be s minus 2, is 1s2, 2s2, 2p6, 3s2, 3p6. And now we have that outermost energy level filled, and there is our octet. Now, if I looked at this notation on the periodic table, I would notice that this notation is going to correspond to a noble gas. Same with this notation. So if I were to look this up, the 1s2, 2s2, 2p6, I would be looking at neon. Because that is our ending where we end with neon. If I'm looking at this one where I have 3p6, this one is argon. Okay, so whenever it gains or loses electrons, it should be forming a notation that corresponds to a noble gas.